Alright, so now we're going to get into the guts of trig, and that is right triangle trig. So most of you, I believe, should have seen this before, so most of what we're going to do here should not be new, but some of it might be, and a little refresher never hurts. So first let's go through a few vocab things and understandings. This is all in your packet. We have 6 trig functions that we're going to be dealing with. Sine, which is abbreviated SIN, cosine, which is abbreviated COS, tangent, abbreviated TAN, cosecant, abbreviated CSC, secant, abbreviated SEC, and cotangent, abbreviated COT. Now, we want to first understand these are all functions. So, similar to when we were dealing with functions in Unit 2, a function might have a name such as f. Then that function was written usually as f of x, which represented the output of that function, where x was the input. The same thing is true with trig. The sine function is the name of the function. It means something very specific, but it's just the name of the function. So we have to have an angle to go with it, that we input that function, or that we evaluate that function at, where the angle is the input, and then the sine of theta is the output of that function. So just having sine by itself, or SIN by itself, is really not going to do anything for you. You need to have sine of an angle. So this is not sine times the angle, it's sine of the angle, just like this is f of x, because it is a function with respect to x. This is a function with respect to theta. Or I'm sorry, a function sine with respect to theta. This is a function f with respect to x. It's very important that we understand that, the function notation. Okay, so now I want you to take a second, label the sides of this right triangle with respect to this angle theta. Pause the video, unpause when you're ready to check. Okay, hopefully you called the side opposite theta the opposite. Hopefully you called the side opposite the 90, or the longest side, the hypotenuse, and the side next to theta, the adjacent side. Adjacent means next to. The hypotenuse is also next to theta, but the hypotenuse is the hypotenuse, so this needs to be the adjacent side. It's very important that we understand these relationships, because these lead us to all of the relationships for these specific trig functions. And our shorthand for that, or our trick to remember that, is Sohcahtoa. You may remember. What does that mean? Well, that means that sine, s, of theta, equals the opposite over the hypotenuse, OH. Cosine of theta equals the adjacent over the hypotenuse, C cosine, A adjacent, H hypotenuse. And tangent of theta equals the opposite over the adjacent. So T for tangent, O for opposite, A for adjacent. That's the Sohcahtoa. Well, what about those other 6 trig functions, the secant, the cosecant, and the cotangent? Well, the cosecant of theta is actually the reciprocal of the sine of theta. So if the sine of theta is opposite over hypotenuse, cosecant of theta is hypotenuse over opposite. Secant is the reciprocal of cosine, so secant of theta is hypotenuse over adjacent, and cotangent of theta is the reciprocal of the tangent of theta, so cotangent of theta is adjacent over opposite. Great, this seems like a ton of information. Let's try and use it a little bit. So if I have this right triangle here, and this angle alpha, and I know this side is 12, that's the adjacent side, this side is 5, that's the opposite side, and we want to find, or we want to evaluate all of these trig functions at alpha. So we don't know what alpha is, and in fact we could find it. We'll learn later on how to find it, but we don't care what alpha is, because we care about what the sine of alpha is, and that we can find without actually knowing alpha, because we know this triangle. So first let's find the third side to the triangle, or the hypotenuse. We can use the Pythagorean theorem. So if I call this x, and I could solve for x, or I can remember that this is a special triangle, and that's going to be 13. So now I want to evaluate all of these trig functions at alpha. So the sine of alpha is the opposite over the hypotenuse. The cosine of alpha is the adjacent over the hypotenuse. And the tangent of alpha is the opposite over the adjacent. Pretty simple, hopefully. Now we want to move on to the reciprocal functions. Well, if sine and cosecant are reciprocals, then I know the cosecant of alpha is the hypotenuse over the opposite. Secant of alpha is the reciprocal of cosine. And cotangent of alpha is the reciprocal of tangent. So the nice thing about understanding that these are reciprocals, and we'll learn more about this and focus more on this later, but it's still incredibly useful now, is that if I know the sine of alpha is 5/13, I don't have to even look at the triangle to know that the cosecant of alpha is 13/5. And vice versa. If I know the cosecant of alpha is 13/5, I know the sine of alpha has to be 5/13. Alright, now I want you to try this on your own. So if you know that the sine of alpha is 5/6, I want you to sketch a triangle and find the remaining 6 trig functions. So pause the video and do that. Alright, so the first thing that's important that you do is draw your triangle correctly. Draw it and label it correctly. So I did 2 separate triangles that give me the same results, and I wanted to point that out to you, that it doesn't matter, you choose where to put alpha. But once you choose where to put alpha, then the sides are fixed based on that. So if I draw this shaped triangle, I can put alpha here or here. Your triangle could be a different direction as well, as long as it has a right angle in it and an alpha. And then you label the sides respectively, or according to where that alpha is. Okay, I needed to find the third side of the triangle, so I can do the Pythagorean theorem. 5 squared plus x squared is 6 squared, so x comes out to be the square root of 11. So now I evaluate the remaining trig functions. Cosine of alpha is root 11 adjacent over hypotenuse 6. Secant of alpha is the reciprocal of that. Well, we want to rationalize. So the reciprocal of root 11 over 6 is 6 over root 11. I multiply the numerator and denominator by root 11, and I get 6 root 11 over 11. So that's how I end up with the secant. Tangent is opposite over adjacent, so it's 5 over root 11, but when I rationalize it becomes 5 root 11 over 11. Cotangent is the reciprocal, adjacent over opposite. And cosecant of alpha is the reciprocal of sine, so it is 6 over 5. Now, if you are struggling or confused about the rationalizing, please see me or talk to me in class, and I can help you out with that, or go to the MRC. I don't have a lot of time on the video to spend talking about rationalizing, but your answers should be rationalized. Okay, next we're going to look at evaluating trig functions when we know alpha. You will notice all of these are going to be at special angles that are from the unit circle. That's not a coincidence. So if I want to evaluate what is the sine of 30 degrees, one thing I could do is type it in my calculator. I don't want to do that yet. Another thing I could do right now is I could draw a triangle. So if this is 30 degrees and I draw my right triangle, I can label my sides. Remember we did this? X, 2x, x root 3. So what is the sine of 30 degrees? Well, the sine of 30 degrees is the opposite over the hypotenuse. But that simplifies, and I end up with 1/2. So the sine of 30 degrees equals 1/2. I can do the same thing here, the tangent of pi fourths. Well, what is pi fourths? I'm not used to dealing with triangles in terms of radians, but I can. I remember that pi fourths is actually 45 degrees. So I can draw a 45, 45, 90 triangle, or a pi fourths, pi halves triangle, and I can label my sides x, x, x root 2. It doesn't matter which one I pick because they're both pi fourths. Tangent is opposite over adjacent. Those reduce, and I get 1. So the tangent of pi fourths is 1. Now I want you to try. So same idea. I want you to find the secant of pi thirds and the cosine of 45 degrees. Pause the video, evaluate those, unpause when you're ready to check. Okay, so hopefully you recognize that pi thirds is 60 degrees. So this is a 30, 60, 90 triangle, or a pi thirds, pi sixths, pi halves triangle. And I can label the sides. Opposite the pi thirds is x root 3. Adjacent to the pi thirds is x. Hypotenuse is 2x. Secant is hypotenuse over adjacent, or the reciprocal of cosine. So it's 2x over x. The x's cancel, and I'm left with 2. So the secant of pi thirds is 2. Cosine of 45 degrees. This is a 45, 45, 90 triangle then. So I label my sides x, x, x root 2. Cosine is adjacent over hypotenuse, so x over x root 2. The x's cancel, and I get 1 over root 2. I rationalize, which is root 2 over 2. Okay, so the big things that we want to understand here are the relationship between the trig functions and the right triangle. So the sine, the cosine, the secant, the cosecant, the tangent, and the cotangent. Also understanding that they are functions. So a sine of theta is much more useful than just sine. You do not necessarily need to memorize these because you will be given them on every test and quiz from here on out for the rest of the semester. However, the more you understand them and the quicker you are remembering them, the easier things are going to be for you.